All right, question number 3. The graph of the continuous function g, the derivative of the function f, is shown above. The function g is piecewise linear for -5 to 3, and g of x is equal to 2 times the quantity x minus 4 squared for the interval from 3 to 6. All right, so the biggest thing before I even start this problem that I'm going to look at, says that it's the graph of g, but it's also the graph of the derivative function f. So this is also f prime. So just keep that in mind as we're going through and being asked problems about it. Alrighty, so part A says if f of 1 is equal to 3, what is the value of f of -5? All right, this is one of those problems where you'll notice that there are two x values given. They're asking something about f when they give you information about f prime, and that's just going to be one of our standard setup of fundamental theorem of calculus problems. So I'm going to go ahead and set up an integral. The two values that I will use will be -5 and 1. We will be taking the integral of f prime. And when I do that, the integral of f prime is just going to be f. So I'll just get f of x. Remember, we get to evaluate it at our bounds. And so that will equal f of 1 minus f of -5. Right now from here, it's just finding some information out. To get the integral of -5 to 1 of f prime, this is f prime. Please remember that an integral, if you're given a picture, is just the area under the curve. So we would like to find the area under the curve from -5 to -1. So it's going to be this section right here. Please notice that that is a trapezoid. So we are going to find the area of that trapezoid. So that area of that trapezoid is going to be 1/2 times the height. The height of that trapezoid is going to be 3. And then the sum of the bases, one of the bases is going to be 4, and the bottom base is 3. All right, so if we calculate that out, that ends up being, I believe, 7 times 3 is 21, 10.5. But it is below the x-axis, so that will be a -10.5. So the area under the curve from -5, well, actually, whoops, I'm speaking incorrectly here. It was not till -1, it was all the way till 1. So we also need to include this part right here. Okay, this part right here is going to be 0. So this part is -10.5. And then the area of this one is going to be a triangle. So it's going to be 1/2. The base of that triangle is 1. The height of that triangle is 2. So the area of that triangle, is 1. So the area under the curve from -5 to 1 is actually -10.5 plus 0 plus 1, which will give us -9.5. All right, and then from here, we'll just continue the problem. It's going to equal f of 1, which they told us was 3, and then minus f of -5, which is what we're looking for. So I'm going to subtract 3 from both sides. I'm going to get -12.5 is equal to -f of -5. And then I'm just going to multiply both sides by a negative to get my f of -5 by itself. So we'll get f of -5 is equal to a positive 12.5. And if you were feeling uncomfortable about changing things to decimals, you definitely could have even left your answer real messy like that as we were working through. All right, we would get 1 point for the proper integral setup. So if we have this setup going on right here, we'd get a point. And then if we got the right answer, we'd get another point. Okay, part B, evaluate the integral from 1 to 6 of g of x. Well, this is g of x. All right, so this picture is g of x, and we want to find the integral, which means just to find the area under the curve. So we'd like to find the area under the curve from 1 to 6. So I'm just going to highlight this whole thing all the way up to 6. All right, please notice that I should not have included this area. Sorry about that. So it's just pretend like I did not do that. Okay, just from 1 to 6. Please notice that from 1 to 3, it is just a square. And then from 3 to 6, we're actually going to be using the curve that they told us of the quantity x minus 4 squared. So I'm going to have to separate this into 2 sections for this one. So if I would like to evaluate the area from 1 to 6, I'm first of all going to evaluate the area from 1 to 3. And then I'm going to have to add the area from 3 to 6 because they are 2 different shapes that we're dealing with. Okay, to get the integral under the curve from 1 to 3, simply, like I said, it's just a square. So the base is going to be 2. The height is going to be 2. So I end up getting 4 as that area. Okay, for this next part, we actually have to do some work on it. We're going to be going from 3 to 6. G of x, they told us, was 2 times the quantity x minus 4 squared. All right. And then in order to get this, what we're going to have to do is a u substitution. So let's let u equal x minus 4. Du will equal 1 dx. Notice we just need a 1, but we have a 2. So I'm going to multiply the inside by 1/2, which means I'm going to multiply the outside by 2. So now this is going to become 2u squared du. The integral of u squared is going to be 2 times 1/3 u cubed. So if I were to rewrite this, this is going to be 2/3, and instead of my u, I'm going to put x minus 4 back in to the third, and then I do have to evaluate it at my bounds, so 3 and 6. Okay, so if I plug 6 in, 6 minus 4 is 2, 2 to the third power is 8, 8 times 2 is 16, so I'm going to get 16/3 minus, now if I plug 3 in, 3 minus 4 is negative 1, negative 1 to the third is negative 1, negative 1 times 2/3 is negative 2/3. So leave change opposite, I'll get 18/3, which is 6. So now I have 4 plus 6, which is equal to 10. So the integral, and I shouldn't have really circled that, I guess, sorry about that. All right, so if you notice that you needed to split the integral at 3 because two things were happening, you would get 1 point. If we properly took the antiderivative of g of x, which I did right down here, we would get a point for that, and then we get a point for that final answer. Okay, part C. For -5 to 6, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. Okay, if I'm talking about increasing, I need an f prime chart. And if I'm talking about concavity, I need an f double prime chart. Please remember that we already established before we started the problem that g was the same thing as f prime. So I'm going to make myself an f prime chart, and I'm going to make myself an f double prime chart. Okay, this is f prime. So if I'm trying to make an f prime chart, I'm just going to be looking at above and below. This graph is below the x-axis till I get to -1. It's on the x-axis till I get to 0. So I'm just going to put a 0 up there. Between 0 all the way to 4, it's above the x-axis. Then it hits the x-axis at 4, but then it is above once again after that. So that's what my f prime chart is going to look like. And then f double prime, if this is f prime, to get to f double prime, we will be looking at the slopes. So if I look at the slopes all the way till I get to till I get to -2, the slopes are going to be 0. And then from -2 to -1, my slopes are positive. Between -1 and 0, my slopes are 0 again. From 0 to 1, my slope is positive. From 1 till I got to 3, my slope is back to 0. From 3 to 4, my slope is negative. And then 4 onward, my slope is positive. Okay, so it's asking where's the graph both increasing and concave up. So increasing would be where f prime is positive. So I'm going to circle those intervals. And then also concave up, I notice here, here, and here. So if I am trying to match up where are those the same, I notice from 0, if I match these two right here, from 0 to 1, they're both positive. And then also, again, if I match these two up, it looks like from 4 till the end of the interval, which was 6. So those would be the intervals, and it did say to give a reason for your answer. So I'm going to say because f prime and f double prime are both positive. All right, and let's see our points on that one. If I came up with my intervals, 0 to 1 and 4 to 6, I'm going to get a point. I'd have to have both of them. And if I properly gave my reasoning, I'd get the second point for that part. Okay, for part D, it says to find the x-coordinate of each point of inflection of the graph of f and give a reason for your answer. Well, we know points of inflection have to do with f double prime. So I'm going to just reconstruct my f double prime chart since I don't have it on this screen. Okay, just a second here. -1, 0, 1, 3, 4, 0 plus, 0 plus, 0 minus plus. Okay, so we do know that a point of inflection occurs where f double prime changes sign. So it needs to go from negative to positive or positive to negative. So all these places where it goes from 0 to positive or positive to 0, those would not be points of inflection. So the only place where the f double prime actually changes sign is at x equals 4. So if x equals 4 is the only place where there's going to be a point of intersection. And then the reason for that is because f double prime changes sign at that spot. So we would get 2 points for that one. We'd get 1 point for our correct answer, and then we'd get 1 point for the reasoning. And problem number 3 is done.